Hi everyone, this is Aditya Rajiv. This is my second video in which I'll be sharing notes on matrices and determinants. So as you can see, I've started from the basics, all the definitions. You can you can pause the video to copy them, or I'll provide them in PDF format. Diagonal matrix, scalar matrix, square, everything is there. Unit matrix, upper triangular, lower triangular, transpose of a matrix, just interchange column and row. And this is important. Multiplication of two matrices a plus b whole square is not a square plus b square plus 2ab. ab plus b. In matrices, ab is not equal to ba. It need not be equal. ab need not be equal to ba. So I think you can copy this down, pause the video. Properties of matrices. A into I is the unitary matrix, as I've written here. I think everybody knows what is a unitary matrix. A into I equal to I into A equal to A. A transpose is A. Symmetric, skew symmetric matrices. Symmetric matrix is a matrix wherein A transpose is equal to A. So when you interchange rows and columns of a matrix, you get the same matrix. It is a symmetric. And skew symmetric matrix is a matrix wherein the principal diagonal elements are all 0. And A transpose is equal to minus A. Minus A. These two are important. A is a square matrix. A plus A transpose, A into A transpose into all are symmetric matrices, and A minus A transpose skew symmetric. Pause the video and then copy the notes. Some points are extra. Idempotent, nilpotent matrix. Nilpotent matrix is a matrix where any number p and a to the power p, matrix a to the power p is equal to 0. Idempotent matrix A square equal to A. Orthogonal matrix A into A transpose equal to A transpose into A equal to I. For skew symmetric matrix, this is something important. Trace of a nilpotent matrix. Trace of a nilpotent matrix is 0. This is not so important, but in case somebody is preparing for some Olympiad or something, it might be helpful. Skew Hermitian मतलब JEE के point of view and CET तो forget. I mean state level exam and all, you don't have to worry about these things. Extra all from here, from complex conjugate, everything is extra. This also unitary matrix, all this is all extra. Just if you are very much interested in higher exams, Olympiads and all, then you can. Otherwise, there's no point. Now, determinant. Determinants is very important. Determinant of A to the power n is determinant A whole power n. This is important property. Determinant AB is determinant A. Each element in a matrix multiplied by A. Each element of matrix A is multiplied by K, sorry. Then that new matrix is what? K into determinant of A. Just remove that common factor outside the determinant. Determinant of A transpose. All important, small important points. Everything is important. Rank of a matrix is also not so important. Rank of matrix is number of non-zero rows minus 1. Rank of matrix not that important, but application of determinants, this is very much important. You can start basic questions from R.D. Sharma and move to further difficult. Area of triangle, half x1 y1 1 next to y2 next 3 y3 1. Condition for collinearity. We had learned this in 10th standard also, but not in this format. That's it. We had learned in which format? The y3 into x2 minus x1 plus half of y3 into x2 minus x1 plus, you know, uh, y2 x3 minus x1 like that. It's some cyclic order, right? It was in some cyclic order. I'm not sure. Or no, no, sorry. It was half of x1 y2 minus y3 y3 minus y1 like that. No, this is not that important. I mean, this part. This rank of matrix not so important, but I've just written them in my notes. Adjoint of a matrix. Transpose of cofactor matrix. Adjoint. A into adjoint A, the adjoint A into A is equal to A into I. All these are important properties. Special properties, very, very important. Adjoint of A transpose, adjoint A whole transpose. Adjoint A, determinant of A power n minus 2 into CET and all, they'll ask direct question from here. A is a symmetric matrix, then adjoint of A is also a symmetric matrix. You can see these notes, copy them, read them, pause the video. If you see that something is missing that's not in your notes, copy them down. It's okay. Singular matrix determinant of A is 0, non-singular determinant of A not equal to 0. These all are important. Entire, this full page, inverse of a matrix. Inverse only exists if determinant of A is not 0 or A is a non-singular matrix. Determinant of A not equal to 0 means non-singular, and then only it will have an inverse. And how to find A inverse? Adjoint of A divided by determinant of A. There is another method to find inverse, which is the CBSE method, which is quite long, but for competitive exams, direct use this one. Determinant of adjoint A, this is also important, where I have just written it not that clearly, but please, this is damn important, very, very important. Determinant of adjoint A, determinant of A ki power n minus 1 whole square. This is n minus 1 whole square only, this part. A ki power n minus 1 whole square. All these are also important. Cramer rule. Cramer rule is also important. Entire determinant is important. I'm sorry if I'm saying important for everything, but entire determinant is important.